Yeah, you got to graph it on a number line. But look, remember on the number line, the number curve, 3 is positive and the negative 2 is negative, right? So the negative 2 goes over here. And now let's graph this one first. We're going to graph less than 3. So we're open on the 3. We're going this way. We are greater than the negative 2. So we're open on the negative 2 and we're going this way. So anything between negative 2 and positive 3 are solutions to that absolute value inequality. Got it? Now, this isn't hard stuff, but it's stuff that you just have to be careful. Alright, the absolute symbol's by itself. So we drop it and rewrite it. So we got 3x minus 4 less than or equal to 8. And then when we rewrite it the second time, it's 3x minus 4. Now it's greater than or equal to negative 8. Yes?
What if the 8 were like a negative 4 here, like before the
Well, you would have to do a little ciphering. It would be a no solution if this negative 8 in this case. Right? Because no matter what's in here, it's going to be positive, and a positive can't be less, or whatever's in here is going to be positive, so a positive can never be less than a negative. But now you got to be careful, because if this thing's pointing the other direction, alright, you're going to have to go ahead and work the problem out and check your solutions. So now we're going to add 4 to each side. So we get a 3x is less than or equal to 12, and we divide by 3. X is less than or equal to 4. There's one solution. Add 4 again to each side. 3x greater than or equal to negative 8 plus 4, negative 4. And divide by 3. X is greater than or equal to negative 4/3. So then when you graph, the negative 4/3, it's over here, negative 4/3. It's to the left of 0 on the number line. And then you got your 4. So on the 4, we're closed, agreed? And we are shaded to the left. On the negative 4/3, we're closed as well. And we're everything greater than or equal to negative 4/3. Or the variable's on the left, so we shade the direction of the inequality. So we shade to the right. And there's where your solutions lie to that absolute value inequality. Good? Alright, let's do an example of a greater than. Let's take a look at absolute value of 2x plus 4. Greater than or equal to 6. Same concept. We're going to rewrite this twice. So So we got 2x plus 4 greater than or equal to 6. We got 2x plus 4 less than or equal to negative 6. Solve them both, graph them both. Subtract 4. 2x is greater than or equal to 2, and then divide by 2. X is greater than or equal to 1. There's one solution. Subtract 4. 2x less than or equal to negative 10, divide by 2. X less than or equal to negative 5. So be careful when you graph again. The negative 5, 0, and the 1 on the number line. Right here, we're greater than or equal to the positive 1, so we're closed. We're going this way now. We are less than or equal to negative 5, so we're closed on the negative 5. And we're going this way. Got it? These greater than or equal to problems. These greater than absolute value, greater than or equal to, will look like this. Split graph. The less than or equal to problems will look like, see where we were less than or equal to on this one, these first two examples, these less than or equal to's will look like this, shaded in between. All right. All right, so let me give you a little bit of practice to do, and you can start thinking about your dinner recipe. Now look, see how this is greater than or equal to negative 9? You're going to have to work it out. Because you can have an absolute value in here that's greater than a negative, right? Because if whatever works out inside the absolute value symbol, it could be positive 1 or a 1. It's going to be greater than negative 9, isn't it? So it's going to be greater than or equal to negative 9 and then less than or equal to positive 9. So you still got to solve it twice. Alright, that's all I got for you for today. Just finish up those 5 and make sure you got them done when you get here tomorrow.